Hello and welcome to my channel. In this video we are going to solve question 11 to 16 from exercise 3.2 matrices chapter. If x times the matrix plus y times the matrix is equal to the given column matrix, find the values of x and y. So let us begin by multiplying x and y with their respective matrices. So x multiplies with 2 giving us 2x, and it multiplies with 3 giving us 3x, plus y times minus 1 is minus y times 1 is y is equal to 10 and 5. Now since the orders are same, that is this is going to be 2 by 1, 2 by 1 and 2 by 1. Using the law of equality of matrix, we are going to add all the first elements and we are going to add all the second elements. So the first equation is going to be 2x plus times minus is minus y is equal to 10, and the second equation is 3x plus y is equal to 5. Now let us add these two equations. So 2x plus 3x gives us 5x, minus y plus y will add to give us 0 is equal to 10 plus 5 is 15. Now since we have got 5x equal to 15, we get the value of x as x is equal to 15 divided by 5, or the value of x is going to be 3. Now once we have got the value of x, let us find out the value of y. Now here I have taken the second equation to find out the value of y. So y is equal to 3x goes on the other side of equal to sign, giving us 5 minus 3x. So 5 minus 3 times, now x value is 3, so we get 3 times 3. So 5 minus 9 gives us the value of y as negative 4. So these are the values of x and y. Now let us move on to the 12th question. Find the values of x, y, z and w from the given matrix equation. Now let us begin by multiplying the given scalar quantity 3 with its matrix. So the first matrix we get is 3x, 3y, 3z and 3w is equal to the rest of the two matrices will remain the same. Now since the order of the matrices are same, using the law of equality of matrix, we are going to equate the first element with the first elements. So 3x will be equal to x plus 4. So we have written the first equation. Now equating all the second elements, that is 3y is equal to 6 plus x plus y. Now third element equal to third element, that is 3z is equal to negative 1 plus z plus w. Now fourth element equal to fourth elements. So here 3w is equal to 2w plus 3. Now once we have got all the equations, let us start with the first one. Now taking x on the left hand side, we get 3x minus x equal to 4. 3x minus x is 2x equal to 4. Now taking 2 on the other side, the 2 divides the 4. So we get the value of x as 2. So we have found out the first value, that is x. Now let us focus on the next equation. 3y is equal to 6 plus. Now in place of x, we have substituted its value, that is 2 plus y. Now taking y on the left hand side, we get 3y minus y equal to 6 plus 2 gives us 8. Now 3y minus y is 2y equal to 8. Now 2 goes on the other side and it divides 8. So we get the value of y as 4. Now in the third equation, we have two unknown variables, that is w and z. Till now we have not got the value of z and w. So let us try to get the value of w from the fourth equation. So taking 2w on the left hand side, we get 3w minus 2w equal to 3. Now 3w minus 2w gives us w. So w value is equal to 3. Now once we have got the value of w, we can move on to the third equation. Now taking z on the left hand side, we get 3z minus z equal to negative 1 plus w. Now 3z minus z is 2z is equal to negative 1 plus w. Now w value we have got it as 3. So plugging in its value, we get 2z is equal to negative 1 plus 3, or 2z is equal to 2. Now 2 goes on the other side and divides 2, giving us the value of z as 1. So we have got the values of x, y, z and w. Now let us move on to the 13th question. If f of x and f of y are given by 3 by 3 matrices of trigonometric functions, show that f of x times f of y is equal to f of x plus y. So here we can see that two matrices are given, f of x and f of y. We have to show that the product of these two will be equal to f of x plus y. So let us begin with the left hand side, that is f of x times f of y. Now here I have written these two matrices, that is the product of these two. So first we have written f of x followed by f of y. Now let us start with the first row and first column multiplication. So cos x times cos y plus minus. So plus of minus gives us minus. So minus sin x times sin y plus 0 times 0. So we do not have to write the 0 over here. Now let us move on to the first row and second column. Cos x times minus sin y gives us minus cos x sin y. Plus of minus is again minus. So minus sin x times cos y, we have written it over here, plus 0 times 0 is 0. Now first row and third column. So cos x times 0 is 0, minus sin x times 0 is 0 again, and 0 times 1 is 0. So the third element of the first row is 0. Now moving on to the second row and first column. Sin x times cos y plus cos x times sin y plus 0 times 0. Now second row and second column. Sin x times minus sin y giving us minus sin x sin y plus cos x times cos y plus 0 times 0. Now second row and third column. Sin x times 0 is 0 plus cos x times 0 is 0 plus 0 times 1 is 0. So here the last element of the second row as well is 0. Now moving on to the third row and first column. 0 times cos y is 0 plus 0 times sin y is 0 plus 1 times 0 is 0. So we get the first element of the third row as 0. Now third row and second column. 0 times minus sin y is 0 plus 0 times cos y is 0 plus 1 times 0 is 0. So here also we get 0. Now finally the third row and third column. 0 times 0 is 0 plus 0 times 0 is 0 plus 1 times 1 is 1. So the last element of the third row is 1. Now if we look at this carefully, cos x cos y minus sin x sin y and rest of the elements represent trigonometric identities, which are trigonometric sum and difference formulae. So here cos x plus y is represented as cos x cos y minus or plus sin x sin y. That is, when we have cos x cos y minus sin x sin y, we are going to represent it as cos x plus y. So here the first element is written as cos x plus y. Now for the second element, we have written it as minus sin x plus y, because sin x plus y is sin x cos y plus cos x sin y. Now here in the second element, if we take the negative sign as a common factor, that is, I have written it over here, minus that comes out. So we are left with sin x cos y plus cos x sin y, which is going to represent sin x plus y. So here we are going to write it as minus sin x plus y. The third element is 0. Now for the first element of the second row, again it represents sin x plus y. Now for this element, it is going to represent this identity, that is cos x cos y minus sin x sin y, giving us cos x plus y. Now this remains as 0, and the last row also remains the same. So this is the representation of fx times fy, and let us consider this as our equation 1. Now let us focus on f of x plus y. Now here I have taken f of x and f of y again for easy reference. Now f of x plus y means either you choose this matrix or this matrix. If you are choosing this matrix, you have to just add y with x wherever x is there. And if you are choosing this matrix, wherever you have y, you have to add x to it. I have chosen the first one. So f of x plus y, replacing x with x plus y, all the elements are going to change as cos x plus y minus sin x plus y. 0 stays the same because it does not have an x. Sin x plus y, cos x plus y, 0, 0, 0 and 1. Now this I have considered as equation 2. Now if you compare equation 1 and equation 2, they are absolutely same. So here we have shown that f of x times f of y is equal to f of x plus y. So let us write here, since equation 1 is equal to equation 2, f of x times f of y is equal to f of x plus y. So we have verified. Now let us move on to the 14th question. Now in the 14th question, we have to show that the elements which we get from the multiplication of left hand side matrices are not going to be equal to the elements got by the multiplication of matrices on the right hand side. So let us start with the first one now. So here we have considered the same matrix. Now let us perform the multiplication starting with the left hand side. So first row and first column, 5 times 2 is 10 plus minus 1 times 3, that is plus and minus gives us minus. So minus 1 times 3 is minus 3. Now first row and second column, 5 times 1 is 5, minus 1 times 4 is minus 4. Now second row and first column, so 6 times 2 is 12, plus 7 times 3 is 21. Now second row and second column, 6 times 1 is 6, plus 7 times 4 is 28. Now on the right hand side we have 2 times 5 is 10, plus 1 times 6 is 6. 2 times minus 1 is minus 2, plus 1 times 7 is 7. 3 times 5 is 15, plus 4 times 6 is 24. 3 times minus 1 is minus 3, plus 4 times 7 is 28. Now let us simplify this matrix. So here we have, now on the left hand side we have 10 minus 3 as 7, 5 minus 4 is 1, 12 plus 21 is 33, 6 plus 28 is 34, and on the right hand side we have 10 plus 6 as 16, minus 2 plus 7 is 5, 15 plus 24 is 39, and minus 3 plus 28 is 25. So we can clearly see that this matrix on the left hand side is not equal to the matrix on the right hand side. So we have proved this. Now let us move on to the second question. Now here let us look at the left hand side, first row and first column. So 1 times minus 1 is minus 1, plus 2 times 0 is 0, plus 3 times 2 is 6. Now first row and second column, 1 times 1 is 1, 2 times minus 1 is minus 2, 3 times 3 is 9. Now first row and third column, 1 times 0 is 0, 2 times 1 is 2, 3 times 4 is 12. Now second row and first column, 0 times minus 1 is 0, 1 times 0 is 0, 0 times 2 is 0. Now second row and second column, 1 times 0 is 0, 1 times negative 1 is negative 1, 0 times 3 is 0. Now second row and third column, 0 times 0 is 0, 1 times 1 is 1, 0 times 4 is 0. Now last row and first column, 1 times negative 1 is negative 1, plus 1 times 0 is 0, plus 0 times 2 is 0. Now last row and second column, 1 times 1 is 1, 1 times negative 1 is negative 1, 0 times 3 is 0. Now last row and last column, 1 times 0 is 0, 1 times 1 is 1, and 0 times 4 is 0. Now on the similar basis I have performed the operation on the right hand side. So you can pause the video and check the answers. Now simplifying these matrices, we get minus 1 plus 6 is 5, 1 minus 2 plus 9 is 8, 2 plus 12 is 14, 0, minus 1 plus 1, minus 1, 0, plus 1. Now similarly on the right hand side we get the elements as minus 1, minus 1, minus 3, 1, 0, 0, 6, 11. I had made a mistake over here, so I have recorrected it. 11, 6. So here the left hand side matrix is not equal to the right hand side matrix. So we have shown this. Now let us move on to the 15th question. Find a square minus 5a plus 6i if a is given by a 3 by 3 square matrix. Now in this expression, a square means we have to multiply matrix A by itself, that is A times A. 5a means the scalar quantity 5 multiplies with the given matrix A, plus 6i. Here I represents the identity matrix. Now identity matrix has 1 as its element diagonally. Rest all the elements are going to be 0. So the 6 is multiplied by I. Now here I have already written A times A. So you can see the matrix A is multiplied by itself, minus 5 times A plus 6 times identity matrix. So let us begin to simplify this. Now here we have done 3 by 3 matrix multiplication. I have explained step by step multiplication of this matrix in the question 3 sub question 4 of this exercise itself, that is exercise 3.2. So you can find the solution of this example in this link above. Minus this scalar quantity multiplies with each and every element. So 5 multiplies with 2, that gives us 10. 5 with 0 is 0. 5 times 1 is 5. And similarly we multiply 5 with rest of the elements. Plus now 6 multiplies with each element of this matrix. So we get 6, 0, 0, 0, 6, 0 and 0, 0, 6. Now let us simplify this further. So here in the first matrix, 4 plus 1 is 5, minus 1, 2, 4 plus 2 plus 3 is 9, 1 minus 3 is minus 2, 5, 2 minus 2 is 0, minus 1, 1 minus 3 is minus 2. And rest of the matrices are same. Now we are going to perform the subtraction and addition operations on these matrices. So combining all the three matrices, we have written the elements as 5 minus 10 plus 6, minus 1 minus 0 plus 0, 2 minus 5 plus 0. Similarly, we subtract and add the elements for the second row and the third row elements. Now this simplifies as 5 minus 10 plus 6 is 1, minus 1, 2 minus 5 is minus 3, 9 minus 10 is minus 1, minus 2 minus 5 plus 6 is minus 1, 5 minus 15 is minus 10, minus 5, 4 and 4. So this is the answer for the above matrix. Now let us move on to the 16th question. If A is equal to a 3 by 3 square matrix, prove that A cube minus 6A square plus 7A plus 2I is equal to 0. Now here A cube means A has to be multiplied by itself 3 times, that is A times A times A. And A square we have seen in question number 15 how to perform A times A. So here A square represents A times A. So we have written here minus 6 times A times A plus 7 times A plus 2 times identity matrix. Now let us begin by A times A. So here you can see that I have written A times A and multiplied this matrix by itself. Now here this is again 3 by 3 square matrix multiplication. So here I have written in details. You can pause the video and check out if you get the same numbers over here. A times A simplifies as this matrix. Now once we have got the value of A times A, let us multiply A times A with A. That is, we are going to perform A times A times A. So here we have written A times A. I have put it in a bracket because we have already got its solution, times A. So in place of A times A, we are going to take this matrix and multiply with the matrix A. So you can pause the video and check out the values you get for A cube. So these are the values which you get for A cube. Now we have A cube, we have A square. We are going to just make use of this expression and check if this is equal to 0. So here we have written A cube minus 6A square plus 7A plus 2I. Now A cube, its matrix is written over here, minus 6 times A square. So this is the A square value, plus 7 times A plus 2 times identity matrix. Now here we are going to just simplify it a bit more further. That is, we are going to multiply the scalar quantities with the matrices. So here in the second matrix, you can see each element of this matrix is multiplied by 6. 7 has multiplied each element of this matrix, and 2 has got multiplied with each element of identity matrix. Now let us perform the subtraction and addition operation of these 4. So here simplifying it, we have written, now taking the first elements first, that is 21 minus 30 plus 7 plus 2. Now the second elements, that is 0 minus 0 plus 0 plus 0. Now the third elements, that is 34 minus 48 plus 14 plus 0. Now similarly performing it for the second row and third row, we get these elements. Now adding and subtracting each element, we get the value as 0, 0, 0, 0, 0, 0 and 0, 0, 0. So you can pause the video over here and check the values and just see if you get a 0 matrix. 0 matrix is one which has all of its elements as zeros. So this becomes a 0 matrix. So we have proved that A cube minus 6A square plus 7A plus 2I is equal to 0. This is the answer. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out these playlists where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.